Let me welcome you to this session on business models and energy efficiency models. This is a session which goes in depth in different type of business models being generated out there, of course with a focus on energy efficiency. And we have a great lineup of speakers today. The first two speakers will present new models for pay-for-performance business models. The first speaker is Marion Santini from REP, the Regulatory Assistance Pilot. And the second speaker on pay-for-performance is Arturo Lapietra from OMNIA ENERGIA. I hope I'm pronouncing it correctly. And then we have as a first speaker Christoph Kahlen from FGH. He's going to talk about new business models that focus on sector coupling. And then I will close the line with a talk on a new type of business models out there that actually aim to be disruptive and really change the system, so-called institutional work business models. So Marion, I would like to give the floor to you.
Sure. I will share my screen, put my presentation up. Hello, everyone. My name is Marion Santini. I work for the Regulatory Assistance Project, who is an independent NGO working on the energy transition. We are a partner in the SENSEI project, which is funded by Horizon 2020. SENSEI looks at pay-for-performance schemes for energy efficiency. P4P schemes are innovative ways to provide finance for energy savings. They are mainly based in the US for the time being, but the SENSEI project looks at how they could be implemented in the EU and at linking the P4P concept with energy performance contracts. This presentation is based on a report which was published by the SENSEI project consortium. The report looks at the experience and lessons learned from P4P pilots so far. We know that increasing the energy efficiency of Europe's building stock is a massive...
Sorry, Marion. Sorry to interrupt. Are you sharing your screen? Because I cannot see your presentation.
I can see her presentation, Modi.
Okay, so it's my problem. Yeah, go on. Sorry about it.
Oh no, it's okay. It's okay. Don't worry. It's good to check these things. So, I was saying that the decarbonization of Europe's building stock is a huge challenge, and we know that we need to increase massively the renovation rate and depth in order to reach our climate goals. What we also know is that the energy system will become more and more electrified and based on renewable energy. And the buildings can help reduce peak energy consumption by providing flexibility services to the system. So we have a policy challenge here to tackle. How can we increase the impact of our energy efficiency policies so that they ramp up to the level of ambition that we need? And how can we reward buildings for providing services to the energy system? In the US, these questions have also emerged, and P4P schemes were being put in place to respond to similar challenges. In the report by the SENSEI project, we have found and reviewed 11 examples of P4P schemes that are quite interesting to look at from an EU perspective. As you can see in this table, most of these examples are from the US, except one which is in Canada and one in Germany. These programs have been put in place by public authorities, utilities, or system operators, and many of them are happening in the context of an energy efficiency obligation scheme. As you can see in the table, most of them target large commercial buildings. I'm now going to explain what makes P4P programs different from traditional energy efficiency support schemes. Let's take the example of a traditional subsidy scheme. In the EU, the majority of energy efficiency programs rely on deemed savings methodologies. This means that assumptions are made about the savings brought by a particular measure. You usually get the subsidy at the beginning of the project based on the equipment that you have bought or installed. What makes P4P schemes different from traditional support schemes is that they make use of energy metering equipment. The energy consumption of the building is tracked, and the data is compared to a baseline, which shows how energy consumption would have evolved in the absence of the measure. If the project is delivering savings, a payment is done, and the payment is proportional to the amount of energy saved. The cash flow structure of P4P schemes makes them different from traditional subsidy schemes. With a subsidy scheme, you usually get the payment at the beginning of the project. For the public authority or the utility that is delivering the payment, there is always a risk that the impact is lower than expected. This can happen, for example, if the equipment is not installed properly. In a P4P program, the payments are issued once there is evidence that the intervention has delivered savings on the ground. And usually these payments take place 1 year after the installation. So with a P4P scheme, the project developer has to wait until energy consumption is measured to receive a payment. If a project does not deliver, there is no payment. So the project developer takes the performance risk away from the public authority or the utility. This said, this figure is an illustration, and in practice, P4P schemes can have slightly different performance and payment structures, and I'm going to say a few words about that now. Overall, the performance rules are quite similar across the examples we have reviewed. Usually, the programs are quite flexible in terms of which measures are eligible, and they often require the use of smart meters to collect data before and after the intervention. In some cases, the building owner is rewarded directly based on performance, while in some other cases, there is an aggregator who is rewarded based on the performance of its project portfolio. We have found quite a lot of diversity in the payment structures of P4P schemes. In some cases, payments were 100% proportional to the energy saved, but in many cases, you also have a grant which goes to the project and which is not based on performance. And this is all often put in place in order to lower the risk for a project developer to engage with the P4P scheme. Because they know they can keep the grant even if the project does not deliver the savings that they were planning to. The price per unit of energy saved can be set in advance by the contracting authority, or it can be the result of a bidding process between aggregators. Sometimes there is a bonus that is provided for more challenging energy savings actions. And what we found as well is that there was a lot of differences in the duration of the performance contracts. The maximum we have found was 5 years, and the minimum was 1 year. I'm going to give you an example to make it more tangible. So here is one P4P scheme that is developed by the Pacific Gas and Electric Company, PG&E, in California. It's the only case study which we have reviewed which targets the residential sector exclusively. And with the deployment of smart meters, we can expect such programs to be replicated in different places in the US, I think. PG&E has selected aggregators to deliver the savings, and these aggregators are rewarded based on the energy savings of their entire client portfolio. So they engage with people living in houses, basically, and these household participants are not rewarded on a P4P basis. It means that the PG&E has its contract with the households, but the households does not carry all the performance risk. PG&E uses the Caltrack method, which is an open source methodology to calculate savings. The compensation that is provided to the aggregators is 100% proportional to the energy saved. The price per unit of energy saved is the result of the bids by the aggregators. And aggregators receive monthly payments from PG&E, so they don't have to wait for 1 full year to receive the incentive once the project starts rolling. They receive payments during 2 years, but what's quite interesting is that the compensation takes into account the lifetime of the measures that are put in place. So the long-term measures are encouraged, even though the contract only runs for 2 years. Let me now briefly run you through the recommendations of the report in view of the rollout of P4P schemes in the EU. So we have found that P4P schemes can add value to the tools that are already in place to stimulate energy savings in the building sector. And for this reason, we recommend beginning piloting P4P programs now. It takes time to find the right program structure, so it makes sense to start small and build on experience. It's also quite important to integrate well with the other measures and objectives so that P4P schemes are actually directed to the measures that make more sense. In the report, we also stress the importance of setting good measurement rules for energy savings. In the EU, member states should be aware of the accounting rules under Article 7 of the Energy Efficiency Directive if they want to value P4P schemes in the context of this energy savings obligation. Smart meters are not absolutely required for a P4P scheme. There's a couple of cases where they are not used, but they allow P4P schemes to be rolled out at a much lower cost. So these two issues should be looked at together. You need to adapt the P4P scheme to local conditions. So that's also why stakeholder engagement is key in the development of such schemes. That came very strongly from the interviews we had with P4P schemes developers. Finally, we recommend that program managers publish the results of pilot evaluation and exchange knowledge about these programs. And we hope that our report can help launch that discussion. You can download it on the SENSEI website. And I thank you very much for your attention, and I'm looking forward to the discussion.
Thank you so much, Marion. Are there any questions? I don't see anything in the chat. Please don't forget to unmute yourself if you want to ask a question. No, so in the meantime, hoping others will unmute. I was wondering, Marion, it's perhaps a little bit of a silly question, but how different are these pay-for-performance models from the ESCO models that we had?
They are linked. So the pay-for-performance schemes are put in place by utilities or by public authorities. So in the case of Germany, the scheme was put in place by a ministry. And the schemes they aim at developing the ESCO model because very often, in the vast majority of the cases, they look at stimulating offers from aggregators. So aggregators would bid in, and the utility or the public authority would provide a performance-based payment to the aggregators to develop their ESCO model. So it's a kind of ESCO for ESCO in a way that ESCOs would get payments for the work they're doing. So it's a bit replacing, or at least it's not necessarily replacing, but it's complementing some of the subsidy schemes you could have by encouraging a culture of performance among aggregators. All these different blocks are not new, so you already have the idea of using smart meters to track savings. That's in the EU. You've seen that in the context of industrial energy efficiency programs, but a bit less in other programs. You also have this idea of performance contracting that already exists, but linking all these things does not exist yet in the EU in view of renovating the building stock, and that's what the SENSEI project is exploring, with the view of developing further the energy performance contract, which we think has a lot of potential to develop further.
Yeah. Very interesting indeed. I have another question, but let's see if there are other questions in the meantime. Anyone who wants to ask a question for Marion?
Ruth, I see there is a question from Elizabeth. So Elizabeth, if you'd like, I can unmute you so you can ask it directly. So if you confirm in the chat, I can do so. If not, we can just read your question.
Okay, Modi, I can't see the question from Elizabeth, so I think we really need you indeed to monitor the chat then.
Yes, sure. I'm unmuting Elizabeth, and once she accepts. Elizabeth, now you're unmuted. Maybe just try to push.
Can you hear me?
Okay. Yes. Hello. Hello.
Hello. Good morning. Maybe good afternoon. Thank you very much for the presentation, Marion. I appreciate that. Do you see the pay for performance model as a mechanism to address such issues as split incentives, particularly for the case of rental properties?
Yes, yes. I think yes, there's a lot of potential for P4P schemes to address the split incentive problem, but also other barriers that we have in the building sector. This said, I think P4P schemes really have to be put in the context of a broader climate and energy policy in the building sector. I think that having P4P schemes on their own would not necessarily lead us to where we need to be. An example which I found was quite interesting was in the US, in the District of Columbia. They have put the P4P schemes, and at the same time, they have introduced an obligation on buildings to reach a certain performance level. And I think you have, let's say, you would have this obligation which would drive the market towards a certain standard, and you would have the P4P scheme which would come to actually reward building owners for putting in place the measures. So I think there is no silver bullet to the renovation challenge we have. But I think that there's definitely a scope for improvement in the different schemes we have to support energy efficiency improvements. P4P schemes can be piloted to see how they can fit in this broader picture.
Okay, thank you.
You're welcome.
So the question I had also in response to your earlier answer is, you said this type of model is like a ESCO for ESCO model. Mm-hmm. And that prompted me to think about a discussion that's going on across Europe. And I know for some countries, like for example Ireland, it's really an issue, namely being that there is no market for ESCOs. So what you see happening there now is that a new type of intermediary business model is being created, indeed, to facilitate ESCOs. So building trust and doing a lot of other activities to actually create a traction for ESCO models. So would you see this kind of model, depending probably on who's presenting it, also as some kind of a facilitation tool for ESCO market creation?
Yes, definitely. I think it depends how the P4P scheme is developed, but what was quite interesting is that in the case studies we have reviewed, there was so two elements. First of all, very often the programs were put in place because the ESCOs actually called for it. So there was actually a call from the market to move towards such programs because they thought this was the right way to go. This would help the development of their business models. So that we have seen in several cases that this was instrumental. I think if there is no market for ESCOs, it is also, I mean, or no, there is a small market for ESCOs. It means that the demand is not necessarily there. So you can have an offer, you can have a business that comes and knock at your house and propose you something, but if you, and that's already very good, that's very useful in some cases. You don't even have business models that are developed enough that they would actually be attractive enough to engage the citizens. But if you don't have a massive demand, we are not going to reach the goals we have set to ourselves. So I personally see the improvements of energy efficiency programs, and P4P is one aspect of that policy development that needs to happen. But I see the development of the efficiency of or the effectiveness of energy efficiency program as one thing that needs to be done. The other thing that needs to be done is creating the demand. And in my opinion, setting obligations for buildings to reach a certain standard by a certain date is something that we will need to look at, because this can be the right complementary measure in order to develop those business models and allow for reaching our climate goals. The European Commission has hinted in that direction in the renovation wave. They will look at setting mandatory minimum energy performance requirements for buildings, and I think that's the right way to go.
Yeah, clear. Thank you very much, Marion, for this interesting presentation and the discussion. I think we can move on to the second presenter, who will also present on peer-to-peer pay for performance type of business models. It's Arturo. Yes, hi, welcome from OMNIA ENERGIA. Good.
Yes, hi, Ruth.
It's yours.
Hi, thank you. Do you see my screen? Sure.
Yes, I see you.
So
yes,
I start. Okay. Good afternoon. It is Arturo Lapietra from SENSEI in Italy. I'm project manager at OMNIA ENERGIA. That is an energy retailer and energy service company, and especially is a partner of the SENSEI project, funded from the Horizon 2020 Research and Innovation Program. This is my agenda, and we quickly jump to the SENSEI project vision. The project is funded by the Horizon 2020 program, and the consortium consists of 13 organizations with both research and business profiles. The acronym SENSEI is for Smart Energy Services to improve the energy efficiency of the European building stock. So we will design concepts and business models that will help to generate a new source of benefits that increase the value of an energy retrofit project by enabling the compensation of energy efficiency as an energy resource, and turn the project's value into an investable asset to attract private financing. As Marion mentioned before, in SENSEI we analyzed the experiences and lessons learned from pilot sites in the US, and now we are working on how to adjust them to a European context. Building account for 40% of the EU's final energy consumption, and as a result, energy efficiency in buildings has been identified by the European Commission as a very real and measured opportunity. But despite its potential, the current building renovation rate in EU is very low, in particular due to the lacking of private investments. For energy efficiency to be attractive to investors, it must be associated with consistent returns and stable long-term cash flows. In this challenging context, the SENSEI project proposes a pay-for-performance business model in the EU which offers an effective way to engage both energy providers and third-party investors in energy efficiency. Pay-for-performance scheme aim to deliver greater and more persistent energy savings by paying energy efficiency resources based on a comparison of metered energy consumption and modeled counterfactual energy consumption. So energy savings are used as the indicator for the energy efficiency project performance. The payments are channeled from an organization which is willing to pay to support energy savings, usually a public authority, a utility, or other entities. Some P4P schemes outside the EU provide an upfront non-performance-based incentive in addition to performance-based payment. This approach helps participants to manage cash flows and financial risks. It is the case proposed in this study, which the energy providers become the entities willing to pay for the rollout of energy efficiency intervention and the P4P scheme. The two purposes of our study are devising classes of energy efficiency measure according to the value of their energy savings for energy provider and estimate the P4P rates that energy providers will be willing to offer in a P4P schemes. The proposed approach is not focused on quantifying the P4P rates, but on identifying which variables and parameters can affect these rates. So we use the acronym EEMS, energy efficiency measures, to refer both measures that decrease energy consumption and the deployment of solution for on-site generation of renewable-based solution for heating and cooling. 5 different ways in which an energy efficiency intervention can modify the load profile have been categorized. So we have measures that reduce the use of electricity without affecting its temporal profile. This is referred to the EEMS that reduces the electricity required to accomplish a specific end-use task. Measures for improved control of electricity consumption. The energy consumption change result from modifying the controlled equipment's duty cycle. Measures that affect both the electricity used and the hours required to perform a task. For example, converting electric resistance water heaters to heat pump water heaters will produce savings that are shaped differently than the underlying end-use load curve. We could have measured that increasing electricity consumption due to fuel substitution. An old gas or oil fuel boiler may be replaced by its pan. And measure that install technology for the generation of electricity on site. In the EU, we are moving away from the feed-in tariff system and towards supporting self-consumption. A promising direction of SENSEI could be a model of self-consumption that is optimized to support the grid. Therefore, SENSEI approach for compensating change behind the meter could support this direction. So different categories have been identified according to the principle which energy is saved. Then we have distributed generation plants, storage systems, conversion from fuel to electric, building envelope, thermal plant, electrical system, and building and automation control system. We structured 4 different tables for evaluating the EEMS. Table A provides an analysis of the quality of the intervention. All technical aspects are considered jointly to leave room for the effect that the measure has on electricity grid. Table B analyzes various technical and economic aspects for the measures considering the user perspective too. Table C evaluates a large number of parameters in order to calculate with some certainty the energy saving by taking into consideration the financial and economic aspects of the energy efficiency measure. At the end of each analysis, a class of goodness is resulted from each EEM, from the higher value, 10 corresponds to letter A, to the lower, 1 corresponds to J. At the end, table X is a function of the analysis conducted in the three previous tables. The classes of EEMs have been contextualized for different sectors: industrial, commercial, and residential. To date, as Marion said before, most of the P4P programs of SEDU have been implemented in the commercial and industrial sectors. In our study, we provided also a residential classification of EEMs, because with the deployment of a smart meter, the procedure for collecting data becomes less complicated, and the cost of wall building measurement and validation activity decrease and become more practical for P4P scheme. In the figure is shown an example of the class 6 result in the commercial sector. After devising the classes of EEMs, the P4P rate concept is devised through the mechanism of the energy efficiency obligation schemes and consider the energy provider perspective. In our vision, the energy provider could be a transmission system operator, TSO, or a distribution system operator, DSO. First of all, we defined the P4P rate as funds transferred per energy saved. On the other hand, a P4P rate could be interpreted as a numerical value that energy providers are willing to pay for each kilowatt hour saved or moved to another time of the day. The basic idea behind the proposed approach is that the energy providers could set a higher value for P4P rates, the greater is the class of EEMs represented earlier. This energy provider could be willing to offer a P4P rate in the SENSEI value chain based on their proper needs and their development plan. This figure shows the energy efficiency obligation scheme mechanism. It sets a target, usually in terms of energy savings, that needs to be achieved by energy companies as obligated parties. The obligated energy companies can be distribution companies, suppliers, or retailers. They have the freedom to achieve the target set for them through range of means. But in our study, we suppose that energy companies could deliver the energy savings target by providing energy efficiency measure directly to the customers. So the energy companies could introduce the P4P rates, incentivizing the SENSEI model to implement energy efficiency interventions as an energy system resource. This will lead to larger savings at lower costs, achieving the energy savings target in a quick and direct way. In order to evaluate the P4P rates for complying with the energy efficiency obligation scheme, distribution companies could use the classes of EEMs mapped in the table C. As mentioned before, table C takes into account the technical economical aspects of the energy efficiency measure and estimates the risk that the cost of the measures will be greater than the savings for each of them. Depending on the class achieved in table C, the P4P rates level will be indicated in accordance with the table at right side of the screen. So the energy company could be willing to pay a maximum value for each ton of oil equivalent saved. The European TSOs incorporates in its strategic planning the aim of a decarbonized economy through an energy transition based on the integration of renewable resources, energy efficiency, and storage systems. In this challenged context, the aggregator of the SENSEI business model could turn to the TSO to receive an incentive following the implementation of energy efficiency interventions, bringing benefits to overall grid. At this end, the TSO may have an interest in financing the EEMS and could support the SENSEI model with economic incentives, defining a maximum value to pay. In order to support the TSO development plan drivers, the decarbonization goals especially, the classification of EEMS provided in Table X is the best fit for the P4P rate definition. So the energy provider could set a higher value for P4P rates if the grid is the class of the EEMS. As explained before, the transition of the electricity system towards complete decarbonization requires the full integration of EEMS in order to reduce emissions on a long-term basis, avoiding the need for costly capacity, lowering carbon emission, avoiding or deferring the need for costly network upgrades, and allowing heating and cooling system to be used more flexibly. Associating these benefits with consistent returns and stable long-term cash flows could result in making energy efficiency more attractive to energy providers and third-party investors. Before we end, please let me take a few seconds to guide your attention to the SENSEI stakeholder community. A few of the benefits you will gain from joining our community is to get the chance to influence the development of the business models, as well as gaining access to our upcoming interactive e-learning system, translating into a remote advantage. It is of course free to join, and you can always unsubscribe. You subscribe by going to our website, where you will follow the link in the top right corner. So this is all for me. Thank you for your attention.
Thank you, Arturo. Are there any questions? I don't see questions being flagged by attendees, but if you have, you can either write them in the chat or put a question mark in the column under your attendee list. Just to bridge until a question pops up. Arturo, I was wondering, there is this whole new trend of community virtual power plants as well, where it's communities who try to do peer-to-peer energy exchange, and at the same time also, in that sense, provide flexibility to the grid. Both ways, so they can either not use electricity when needed, or they can be a retailer and provide energy. I was wondering if the peer-to-peer type of pilots would also work with a pay-for-performance model.
Yes, surely. But it's important to highlight that there are two different approaches: the P4P scheme and the community, the energy community as we entered in European Union. Because in a P4P scheme, we suppose that the intervention should be made on a large scale. In the business model that we presented, we see different actors, and these actors are the end users, the power system operators, and the main figure, as already Marion said before, is the aggregator. That is an intermediary between the system operators and the ESCO, and then the end user. But it's very important to highlight that in pay-for-performance scheme, the core figure is the third-party investor, because our challenge is to introduce this figure as private investor. in this scheme and to engage them in order to finance iron model. And this is an approach completely different from the community, in which surely could be integrated in a P4 performance scheme, because the community could provide a very large number of building stocks. Mm-hmm. So surely could engage and could make more reliability and reliable and more persistent the P4P scheme. But the two mechanisms, the two models could be integrated, in my opinion.
In the meantime, is there anyone who has a question? I'm looking at the screen with the questions, but I don't see anything popping up. No, nothing, I think, Arturo. So thank you very much for your presentation. And I think we can move on to Christoph, who will present on new models for sector coupling.
Thank you.
Thank you, Arturo.
Thank you very much. I hope you can see my screen.
Yes, we can, but we can't see you. Do you want the camera or not?
Okay, I can also turn on the camera, of course. So, should work now, right?
Yes, we can see you.
Okay, perfect. Yeah, then thank you very much. As you already introduced, I would like to present the finding of a research project we are involved in, and this project is called Planet, and the focus is rising sector coupling business models supporting the transition to a low carbon economy in Europe. Here, just to give a short overview about the facts and figures of this project. Planet means planning and operational tools for optimizing energy flows and synergies between energy networks. We started this project in November 2017 and actually hoped to be able to finish right now, but unfortunately we will have to extend the duration of the project a bit, probably 3 or 4 months into the next years. Also, as the projects presented before, we are funded by the European Commission in the Horizon 2020 program. The total budget is about 4 million euro, and we have about 10 partners representing universities, scientific organizations, but also grid operators and so on. And well, what is the challenge we all face and we want to work on with this project? Of course, the main background is that the European Union aims to be climate neutral by 2050. This aim has become even more strict and challenging during the last days and weeks, as probably all of you know. Of course, all different sectors have to contribute to this reduction of greenhouse gases. This means that not only electric power generation, but also industry, transport, buildings, construction, and agriculture need to contribute. Anyhow, it seems that the power generation sector can contribute a significant part here. And of course, therefore, it is necessary to integrate more renewable energy sources into the grid, but then also to make sure that the energy produced there is really also used. And of course, to accomplish this integration of renewables, there are several general approaches that can be thought of. Of course, one would think of enhancement of grids, which means then building of new power lines or investing in other primary technology components. Another point, of course, would be the provision and use of flexibility. I think this is an aspect that also has been mentioned in the previous presentations. And a third point is, of course, what is called sector coupling, meaning the conversion of electrical energy into various other energy carriers, which can be heat, but also gas, for example. Yeah, the challenge, of course, is on the one hand to integrate renewable energies and to reduce greenhouse gas emissions, and on the other hand also to maintain reliability and stability of the electric grid. And here the project Planet focuses on sector coupling, yeah, on the following slides I would like them to describe the approach we go for. Yeah, what are our objectives within the projects? Basically, we go in two directions. The first direction is to optimize network planning. And here, the Planet project wants to help smart grid actors to guide future network planning activities by developing a decision support system that can identify feasible sector coupling pathways in order to avoid, yeah, let's say, problems with regard to infrastructure exploitation, but also measures that permit the large-scale integration of renewable energy sources. And yeah, what we see in this diagram is just a basic scheme here of the main components that, of course, are of high importance: electric grids, gas networks, but also distributed heat networks. And within the Planet project, we consider all of these aspects. We develop models for the electricity, gas, and heat networks. We also develop models for conversion and storage technology. Here we see, for example, power to gas, combined heat power units, central power to heat or centralized power to heat units, local power to heat units, but also what is called here VES, virtual energy storages. And here we especially consider actually residential buildings, which have, of course, let's say, some kind of inertia themselves that can be made available as a means of source of thermal energy mainly. So the first point was then, let's say, support in network planning activities and also making decisions with regard to whether to invest in classical grid enhancement, but maybe also in sector coupling technologies or storing technologies. The other point is then the network operation, and here Planet provides a holistic optimization framework both for network planning but also for day-ahead operational planning objectives. And here the project develops, let's say, a tool or a platform which is depicted here in this diagram. This Planet tool, of course, has a user interface leading to a decision support system and orchestration cockpit, as we called it, where the various measures then are organized. And this decision support system of course, has access to grid simulations on the one hand, but also to demand models, supply models, and asset models on the other hand. And then, of course, there's also an optimization algorithm, which then provides the optimum use of the various energy carriers at a certain time. So, yeah, now we had the more or less theoretic thoughts of what we could do within this project to provide support in network planning and also network operation. But of course, it's also then important to think about practical application. And here within the Planet project, we identified various use cases. On the next slides, there are only, I think, 5 of them, but in total, we identified many more. I think in total, we investigate 18 use cases within the project. And here, of course, I can only invite the audience to get in touch with other, or also to have a look at the project website to get more details. Here now just the main use cases we investigate, and here we have the first one, power to gas deployment for system control, and this means that that we have large, for example, we have large power to gas or power to heat units located quite close to renewable energy sources, so that in case of excess electric energy provided by these renewable energy sources, this can be used in power to heat or power to gas systems, and avoid congestions in the electric grid, and also to avoid that renewable energy sources have to be cut off, for example. Another case would be virtual energy storage in buildings. And here it's the focus to identify and apply time shiftable electrical load profiles, especially for heating purposes, and so making use of the building's flexibility in here, which means inherent thermal inertia of the building, and of course then it might also be necessary to use smaller heat pumps here. The diagram here shows what could be the case in a residential building, which can be heated on the one hand with a gas boiler, with a heat pump, and also with a heat storage, which can then also be heat storage in terms of, let's say, storage of hot water for supply in the apartments. And depending on what is available in terms of electric energy, in case of gas, also including prices or current prices, then optimized way of operation of gas boilers, heat pumps, and storages can be found and then also used. Yeah, well, there are many more use cases. On the one hand, number 3 would be small-scale cogeneration for grid stabilization and heat generation. Cogeneration here means, on the one hand, supply with electricity coming from renewable energies resources, ideally, and on the other hand, combined heat and power units. And here the focus will then be to support the electric grid in times when renewable energy resources generation abruptly drops and cannot satisfy the need, and this imbalance can then be compensated by using combined heat power units. Next use case would be centralized heat pumps for hot water storage in district heating plant facilities, and here the focus is on operation of high power heat pumps as a main device for solving electricity network congestions. So if there's an excess of available electricity coming from renewable energy resources, this can be used then by means of heat pumps for hot water storages. And the last one of the use cases presented here would be the utilization of power to gas processes to reduce industrial emissions and to produce synthetic natural gas for green district heat production. This is maybe a bit a complex case here. It aims at districts with for example, with industries, with also carbon-intensive industries, for example, which can then integrate power to gas units in their sites to absorb carbon coming, for example, from flue gases, and so reduce their carbon dioxide emissions. And then the waste heat can be fed into district heating networks, and the synthetic natural gas can be fed into the gas network. So quite an ideal scenario for coupling of various sectors. What I just described is also more or less depicted in diagram of this slide. We have here on the bottom, there is let's say an industry which emits flue gases. Then, for example, CO2 capture technologies, methanization can be used to generate or to produce synthetic natural gas, which can be stored or fed into the gas grid. Then, of course, we also have aspects like renewable electricity, which can be fed in the power grid on the one hand, but also via electrolysis be transformed into hydrogen, which then can contribute to methanization and so on. So this is quite a complex case we consider here. What I just described were use cases, which are of course mainly driven by let's say thoughts of what is feasible from a technical point of view and what can be imagined. In order to bring these use cases then also to application, of course, business cases are also important. So one has to think about under what conditions it's also from a business point of view a feasible way. And here also driven by the use cases, we develop and investigate various business cases like grid congestion management. I just described the virtual utilization of power to gas processes to reduce industrial emissions and produce synthetic natural gas. Others are business cases like centralized power to heat and heating, combined heat and power and heat storage, and so on. And there are actually quite a lot of more business cases which we develop and investigate here within the project. What I here, of course, have to admit that the quantification, especially of the business cases, is something we are still working on. As I said, we are a bit later in the progress of our project than expected, especially because one main part of the project are also field tests. So we wanted really to apply all these use cases and also business cases in large field tests with our partners in Italy and France especially, which then had to be postponed quite a lot due to lockdowns due to the corona crisis right now. So we hope to be able to to catch up here within the next month. Well, let me come to the conclusions. Yeah, well, in general, in an integrated energy system comprising all three carriers, and three carriers here are electricity, heat, and gas, the decoupling of demand and supply through conversion of electricity in other energy sources increases the degree of substitutability between them. Yeah, so yeah, the main point is here the conversion, of course, not to forget also the storage then of gas or heat. Then this allows end users to cover their basic needs, which is of course supply with electricity, but also heating and also gas, yeah, to satisfy these needs through different energy sources. With help of the Planet project and the decision support system that is developed here, an ideal way for covering all these needs can be found. And then, of course, this also enhances energy market competitiveness in general. And that's another important point. In order to exploit this described business opportunities, new regulation is needed, but also incentives, for example, for the adoption of yeah, for these conversion technologies, also thinking of investments and costs in general. But these are, of course, points we are working on right now. And yeah, well, that's already the end of my presentation, and I would be glad that if you have a look at our project website or get in touch with us directly also for further discussion. Thank you very much.
Thank you very much, Christoph. That was a totally different but very interesting presentation. In order to allow people to start writing up their questions, I have a question for you, of course.
Yeah, sure.
I was wondering if you would have to sum up the biggest challenges to the new type of business models that would be needed for this type of connection, sector crossing connection. What would those be? You mentioned already new regulation and incentives needed to be in place, but I was wondering, is there also something that needs to change in the way stakeholders work together in partnerships, for example, in business models to make this happen?
Sure, I think you mentioned an important point there, that the cooperation between partners that until now have not been, let's say, typical cooperative partners, but just have been in a, let's say, supplier and customer situation. If I think about management of large residential or industry areas and production sites, for example, then of course they would not just ask for connection to the grid with certain power rating, but they of course become providers of energy, of gas, of heat as well, which is then made available by them. So their role, of course, changes. And of course, apart from pure thinking of technical feasibility, that also means that then these actors think about their roles and assume new roles and also become much more active.
Yes, I think it's also something I will touch upon in my own presentation. What you see happening in the market is that when these type of new business models emerge that actually provide more of a service instead of a product, yeah. A lot of things need to change in the way that service is being provided, and collaboration in a different way than the traditional value chain collaboration is a necessity, and the service needs to be provided in a seamless manner to end users, and that's really a big challenge indeed.
That's a big, yeah.
Sorry.
Oh yeah.
Any other questions from our audience? We have a bit of a quiet audience today.
Yeah.
It's a pity. Yes. So I invite you, audience, please provide a question for Christoph.
Of course, otherwise it's also possible to get in touch with us after these meetings or the conference. Yes. We are always happy to receive feedback there, even if it's not now in this rather small group. I don't know.
Well, I'm certain that the presentations will be made available, and the contact details are on it.
Yeah.
Okay. No questions. Then we move on.
Okay. Thank you.
Thank you very much, Christoph. All right. Can you see my presentation screen?
Yes, Ruth, we can see it.
Good, good. It's difficult because the presenters can't see their own screen. So welcome to this presentation. I'm going to talk to you about work that we have been doing for the past years as part of a program, one of the collaboration programs run by the International Energy Agency under the Technology Collaboration Program on User-Centered Systems. It's a project that focuses on new business models and especially tries to answer the big question which has been popping up in the past few years in response to this enormous sense of urgency that we of course all feel, that the previous presenters have also discussed, which is we need to reduce consumption, change to renewable energy sources, and all of this creates a lot of market, you would think. However, that's not really the case somehow. A lot of the entrepreneurs and services being developed out there actually are experiencing quite a big problem. So as I said, this is part of the Users Technology Collaboration Program by the International Energy Agency. And what we have been doing actually is analyzing the uptake of more user-centered energy services and new energy business models. Why? Because there is this very slow market uptake, as I said, of these innovations and business models, and a lot of researchers, policymakers, and of course industry have been wondering how this is as it is, what the reasons are behind this slow uptake, in spite of the fact that there are so many good innovations, both technical and social innovations. So what we found...
Sorry to interrupt, Ruth. I'm
Yes.
sorry. Are you presenting your presentation now? Because all we can see is your desktop, the flowers.
Oh, that's strange. Yes, I am presenting. Yes. Wait, I have two monitors on. So let me see what if I switch to just one monitor. Does this help?
Now it works. We witnessed some successful business.
Exactly. Good. Okay. Well, technology. So as I said, what we have been investigating is the type of business models out there that somehow do make it and are successful in being uptaken and actually achieving a larger market share. And what we saw is that these type of business models, and they have a few key characteristics, and not only in terms of the business model itself, but also in terms of the entrepreneurial system behind them. So first of all, and in my next slide I will discuss this a little bit more, we saw that those business models that are more service oriented, that means that they are different in all the key elements of the business model compared to a product oriented business model, are more successful. they have a higher market share, a more diversified market share, and they generate more turnover than those that do not. However, to deliver a service-oriented business model, you actually also need a certain set of capabilities as an enterprise or as an entrepreneur. First of all, what we see is that those type of businesses are really good at sensing user needs. Certainly also those that do business to business to consumers in a way, they still are able to provide multiple value to different type of users. But they are also really apt at understanding and sensing the context around them. And I'm not only talking about competition, but also, for example, about changing landscape in the sense of regulation and norms, culture, etc. A second capability that they have is that they know how to scale. They know what that means in terms of your organization, the team competencies that you need, the plans that need to be put in place, the processes that need to be put in place, but also, of course, the whole communication, marketing, etc. And those businesses all have a very good back office that really aims at providing support to the users. A third key capability, and the previous presenter also mentioned this, is that when you're delivering a service, usually it's a more integrated system of individual components, technologies, products, etc. And what that actually means is that there needs to be orchestration, like when you have a music choir, you need to actually make sure that everyone sings the right song and the same song and know their position and their role in delivering this service to the end user. And these businesses are really good at either orchestrating all the other partners in their service, or they know how to be part of this orchestration. And then finally, and perhaps it's the most important skill that these entrepreneurs demonstrate, that's the skill of conceptualizing. That means that because they sense user needs, and not once, because it's not a transactive relationship they have. When you deliver a service, I will come back to that in a minute, you have actually a very long-term relationship with your clients, your users. That means you have a lot of feedback loops. And because of those feedback loops, you get a lot of feedback, of course, on your service. And if you want to maintain a good relation with those users, what you actually need is to conceptualize. It means continuously, iteratively renew actually your proposition to make sure it adapts and evolves with the users. So as I said before, it also requires a very different type of business model than the traditional product-oriented business model. I don't know if you are familiar with the business model canvas by Osterwolder, Pigneur, and others. There are many other canvases out there. It doesn't really matter actually which one you choose, as long as you don't see it as the solution to your issues. We use this one because it really identifies key elements that need to be put in place in a business model. And what you see is that a product-oriented business model looks like this. Partners are in a very vertical value chain relationship with one another. There are resellers or suppliers, etc. The resources are really seen as technological and knowledge type of resources. The value proposition, it's tangible. It's something you can feel, smell, holding your hands. It's a product. It's a technology, a gadget in a sense. And the relationship you have with your customers is actually almost a one-off. You have a sort of a relationship with them until they buy, and then if you're lucky, you never see them again. So that is really different from a service-oriented business model. I see now we have customer segments instead of customer segments. I'm sorry for the typo. And of course, the cost structure and the revenue system is completely different, because in a product-oriented system, you pay per unit. When you have a service-oriented business model, you actually pay constantly throughout the years, almost on a monthly base or a fee base, anything else. The partners in a service-oriented business models, they act as a network. They collaborate to actually propose a value proposition to the customer that is changing all the time. So you see the value proposition also differing in time. Actually, a good service business model after a few years should not propose the same value as it did when it started, because then it didn't do its job in a way. So a lot to tell about this, much more than I have time for, so let me move on. What we also saw is that although those service-oriented business models do better than those that focus on delivering products, still many really good service business models that are well designed still fail. So what we did in the past 2 years of this program is that we did a lot of case study analysis of those well-designed business models, different types, from microgrids to peer-to-peer and flexibility services to retrofitting as a service, etc. Total solutions as well. And we analyzed them according to, of course, as you can see, the business model canvas, but also the servitization capabilities I discussed, the sensing, conceptualizing, etc. But we also wanted to understand what makes them fail and how the system that they operate in, which is a system that is in transition with its own barriers, actually impacts the business model, and what the business models do or change in reaction to that. So one of the key findings from this analysis is that actually all of those entrepreneurs, we say many, but it's actually all of them, they mentioned five similar type of barriers that they are facing. And all of these actually have to do with the fact that we are in transition with the system. And this transition creates a lot of complexity because everything is interconnected, and if one element has to change, the rest needs to change as well. There's also somehow no governance, so there is not a very clear leadership as to where we go. Outcomes are uncertain, even in terms of what kind of technology path is going to be decided upon and chosen. It's a 1,000 blooming flowers out there, and no way actually for entrepreneurs to tell what path to follow. There's a lot of contestation, so there is not yet consensus on, for example, what is the right technology. Look at what happens around hydrogen or biogas or other types of sources or carriers or technologies. And what these entrepreneurs also all mentioned is that actually when they try to deliver a service, they are being responded to by the system as if they are a product. And I will come back to that a little bit later. Well, some of those entrepreneurs reacted with, oh my God, I don't know what to do. And they start ignoring the system and just do what they do and fail. Others try to really resist the system and go ahead in spite, they fail. Some try to collaborate and change, but what sometimes happens is that they actually instead of challenging the system, they help it optimize towards the fossil fuel-based system. Another story, I don't have time to tell you. Some wait and look at what others do and then follow. But there is also a very interesting type of business model and entrepreneurship out there, which actually, and that's the forward arrow, takes leadership and provides a service in response to those transition barriers. So it provides a solution to this complexity and uncertainty and lack of leadership, etc. And they do so with a very specific additional set of capabilities. So in light of this complexity, they create collaboration and provide multiple value creation to stakeholders. In light of this irresponsibility or lack of leadership, they demonstrate leadership, they start orchestrating collaborations, fulfill intermediary roles. So I think the pay-for-performance type of models are such a intermediating new type of model. In light of the uncertainty that comes with transition, they really anticipate, they do forward-looking scenarios, they negotiate, and actually they try to create the future that they need for their business model. But they remain very flexible in the value proposition they provide to make sure they can adapt it to changing circumstances. In terms of the contestation, what they do is they try to accommodate the diversity of opinions and conceptualize value propositions that allow for those diverse opinions to exist side by side. And in terms of this block that they feel the system is negotiating as with them, they really very interestingly know how to actually connect to individual stakeholders and provide to them the value that they need, building long-term relationship and even start changing the system. This is a more complex model, but what we see is that actually these type of enterprises and business model, they demonstrate agency as it's being called. And they do institutional work. So they actually achieve to change regulations, to change culture, beliefs, norms, by, first of all, setting or using a very clear set of skills that I just discussed, but also by creating authority and becoming an authority in themselves. They time very well how and when and where to put in their proposition. They are, of course, successful in generating financial capital, but they also build a very strong social network, including political capital, for example. And part of what they do is actually creating the new stories out there. So, for example, we have some flexibility cases. And what they do, they co-create the whole story that municipalities, governments, etc., but also users, stakeholders tell about flexibility services and make sure that their business model and their service is part of the solution in that story. As I said, even for these type of entrepreneurs that are called institutional entrepreneurs because they are able to change institutions, the system is still very problematic. It's very product oriented. You see it in everything. You see it in, for example, subsidy schemes that do not allow subsidies or incentives for complex integrated systems to be developed. The subsidy scheme is not about the process leading to system integration, where that's really necessary to finance, because there is not one owner of that activity. It's a societal activity that needs to take place, but the business models are somehow asked to pay for it on their own. There's a lot more to say about this, but just to give you a sense of how product-oriented the system is, and as such not facilitating the uptake of these type of really important services that we need, because we need all of these type of services to actually make the transition happen. So this is the final contact sheet. As you see, it's an international project involving Ireland, the Netherlands, Sweden, and Australia. I'm the operating agent. If you have any questions, please contact us now, of course, or later. Thank you. So now I have the pleasure of actually moderating myself and asking if there are any questions. Marion.
Yes, thanks a lot, Ruth. This was really interesting. I was wondering, have you seen some elements of institutional entrepreneurship in the renovation business? I know a couple of cases, but I'd like to hear your view on that.
Yes, absolutely. There are several of those out there, and they are very capable of actually changing also elements of what needs to be changed in the system to allow for a more effective renovation. So they would be beautiful examples also to follow in the renovation wave that's now launched. In the Netherlands, there are a few beautiful examples. And actually also not only from entrepreneurs, I mean, institutional entrepreneurship can also be initialized by intermediary agencies. And this is, for example, happening in the Netherlands, where a agency for entrepreneurship with the support of the ministries involved have actually provided a subsidy scheme that allows for this subsidizing of the process needed to create better collaboration across, for example, housing corporations and providers of solutions, so that they collectively are supported to create the value proposition and are, in that sense, helped to accelerate and scale up with actually quite innovative but standardized new measures.
Thank you.
You said, Marion, you had some beautiful examples as well. Could you tell a little bit about those?
I was thinking about also this Dutch example, and I was thinking about Denmark, where companies have actually come together to try to set up a new business model. And I have the feeling that they were also active in trying to improve the rules around it, so the rules that would make their business better. But I still think there's a lot that can be done on that. And also just maybe as a follow-up, do you see a role for energy communities in that?
Absolutely, yes. Some of our most beautiful cases are communities taking leadership in this and becoming actually strategic partners also for municipalities. But not only communities, also universities that try to, for example, create microgrids on their campus areas. There are beautiful examples as well of new business models being developed that actually change the system and provide guidance as to what type of regulation would be needed, for example, to allow those microgrids to participate in the whole flexibility market. So there's a lot of beautiful examples out there. I think one of the steps that should be undertaken is actually making them visible, putting them on a pedestal, and making sure that we learn from them, and especially that policymakers learn from them, because they are the front runners demonstrating where the pinches are in the system. Any other question?
I believe no, Ruth, but then it might be because we have 4 other workshops running parallel to this one. But
Yes.
to our audiences, if you have any more questions, you can always drop it at sustainable places at @artomsolution.com, and we can easily direct it to our speakers.
Perfect. So then this is coming to a close. I would like to thank all the presenters for very interesting presentations. I hope the audience has experienced a nice session and has new ways of thinking about new business models. And thank you very much to the presenters. And I hope to see you live someday.
Thank you.
Thank you. Bye bye.
Bye bye.
Have a good day. Bye bye.